Lesson 10A4B, which is really 11.3 in the textbook. Surface area only of rectangular prisms today. For a moment, I want you to go ahead and pause whatever the assignment number was, page 307 and page 309. Pause, check your answers, come back when you're ready, please. All right, ladies and gents, goal for today is twofold. I'm going to focus on the action words, distinguish and find. So the very first thing that I want us to do today is to understand the difference, distinguish the difference between surface area and volume. Then, once we have that difference, ladies and gents, then we can go ahead and actually find the surface area. Now, here's what I mean. So if you're looking at this building, and let's say you're in heating and cooling, and you want to know how many cubic feet of air is there inside that building so you can make sure that your equipment has enough strength, right? That's volume. But what if there's a big, I'm thinking about the news, a big chemical spill, and they're worried about the facade of the building, and they want to wrap this building up with squares of plastic until they can get that chemical spill under control. That, ladies and gents, is surface area. How many squares would it take of wrapping paper, of wrapping paper for a present, of plastic to cover up a building, something like that? So know the difference and then find the surface area. Sooner or later, we're going to get to composite figures like this little roll of paper towel where you have maybe a hollow part. But for today, surface area of rectangular prisms, no matter what the date, no matter what the assignment number. Pause for some notes. I do have it as a worksheet. Some of you rightly put all your work and answers into your notebook. Pause, come on back when you're ready. All right, so first, I know we're not in class, but if you'd like, pause your video. I want you to think of these questions. So what do you think surface area is? What are we finding when we calculate surface area? And we kind of already talked about this. How do we think of surface area as of a rectangular prism? How do you think you find it? So again, we are talking about squares of wrapping paper to cover a gift. Not the volume of that gift, not the air inside, not even the ribbon that goes around the gift. That would be one-dimensional. Volume would be three-dimensional. So we're looking for a two-dimensional area. And that, by the way, all areas are two-dimensional. If I took that and I flattened it, even if I took a soccer ball and I flattened it, there's probably better drawings than that, but they have to make a soccer ball from flat pieces of leather or plastic, right? And then they put them together. Today, our only focus, you see all sorts of three-dimensional shapes that are flattened here. Our only focus is on rectangular prisms. Now, if you were in class, it would have been nice if we had time to do this. I would actually ask you to cut this out, fold it up into a three-dimensional prism. But then what I'd have you do is I'd have you flatten it back again, and I'd say, okay, what's the area of each of these rectangles? So if you went back and you counted, there's one on the left, 2, 3, 4, 5, 6. So if that's 6, that's 6. And then we got 1, 2, 3, 4, 5. I believe that is up to 11. So in fact, you can find the area of this blue rectangle, this blue face, is 66. Let me go ahead and make that pop a little harder. There we go. Let's go ahead and now find the red one, which, oh, that's interesting. It shares an edge, so that also will be 11. Is it the same 6? 1, 2, 3, 4, 5, 6, 7. It is not. This is 8. So 8 by 11 is 88. Again, I'll use black to make that pop a little bit. But we found that each of these rectangles is 8 by 11. Okay, down to the blue one underneath of that, which is still 11 by 1, 2, 3, 4, 5, 6. Okay, 6 by 11, that's interesting. And then we look at the red one, 1, 2, 3, 4, 5, 6, 7, 8 by 11 is 88. Some of you are noticing a little bit of a pattern here. Let's go to the green, shall we? Now we already know that that is 8 because we see it shares the 8. 1, 2, 3, 4. Well, that makes sense that this is 6. After all, if you folded these down, those edges should match up. So an area of the green rectangle on the left, 6 by 8 or 48 squares, and on the right. Okay, how can you use those areas to find the surface area? You already know. If we added up the 66s, the 88s, and the 48s, you're going to get the surface area. And of course, what did you notice? Are there any alike? Well, sure, Mr. Callan, the reds are the same. The front face is going to be the same. The front face is going to be the same as the rear face. And the side face, let me do that in green. The side face on the right is going to be the same as the side face on the left, and so on and so on. So you start seeing that some of these rectangles are alike. Let me get into another example here. So we have a rectangle whose dimensions are 10 by 4 by 8. And you might think, oh, okay, jump in. No, wait a second. We don't want volume here. I want us to draw a net of the rectangular prism whose dimensions are 10 by 4 by 8. And then we're going to use that net to actually find the surface area of such. Now, some of you might struggle a little with this. You might go ahead, like just kind of trace in your mind that front rectangle and then build it from there. So there's one on top and one on bottom, and then the front and the back. Oh, and don't forget the side faces, right? Some of you will prefer not to draw nets. You would prefer to draw individual faces. Here's what I mean. It's nice to have a pencil, ladies and gents. It is oh so nice to have a pencil because you can color in this rectangle and then you can redraw that. And if that base is 10, base length of 10, and if that is, oh, okay, so that's 8, so that's got to be 8. Now I could do the same front face, writing 10 by 8, and as you realize very quickly, it's going to have an area of 80. Now something you should know, if you just draw individual faces, you're going to have to realize that there's 2 of these. We'll come back to that. So at this point, we have one of these on the net, but that means that it's got a buddy whose area is not surprisingly 80 as well. Now let me go to the top and bottom faces, which are congruent. And again, because there's a top and a bottom, we got 2 of them. I see a base length of 10, and it appears to be 10 by 4, which naturally is 40. Don't forget you got 2 of them though. So I'm going to draw the same thing on my net because some people prefer nets. We got 10 by 4, and not surprisingly, that's another 10 by 4. Are we finished? No, sir, no, ma'am. We also have a left and a right side faces, I guess you could say. So I'm going to draw that. I'm going to point out that there's 2 of them. And I'm seeing 4 by 8. So I'm going to write 4 by 8. Although if you wrote 8 by 4, that's okay, because after all, 4 by 8, 8 by 4, both 32. And if I were to draw those on my net, again, that 4 should fold over for a 4. That 4 should fold over for a 4. So you should still see an area of 32 squares. Same thing over here. All right. So now, ladies and gents, what we're going to do to find the total surface area is we're simply going to add everything up. And by that I mean 2 80s, which happens to be 160. 2 40s, which not surprisingly is going to be 80. And 2 32s, or 64. So either way, you may draw either one of these, the left individual faces or the right net, because they're both going to give you all the area of the entire rectangular prism. Now, if I add this up on the right, 2 and 2 is 4. Let me see here. 8 and 8 is 16, and 4 is 20, 24, and 6 is 30. So let's just check it just for kicks. 0, 0, 4. Yep. 6, 8 is 14, and 6 is 20. Carry the 2. Oh, wait, Mr. Callan, slow down. What is it we're measuring? Is this going to be square centimeters, cubic centimeters, or just plain old? No, 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 no. We want an area. We want to know how many squares of wrapping paper would it take to cover this box. And in this case, we found out that it would take 304 of those square centimeters to cover the entire box. Now, at this point, you might have noticed something that maybe is going to be familiar from Second grade. No, not second grade, sixth grade, maybe. Fifth grade. I don't know. Mr. Callan, I hear what you're saying. We double because we got two of everything, but I'm seeing two rectangles that we could call length times width, two rectangles that we could call length times height, and then two rectangles that we could call width times height. So ladies and gents, this is what we would call the surface area formula. Surface area is equal to 2 times length times width width times height. Now at this point, you might be saying, okay, Mr. Callan, but what's the length, what's the width, what's the height? If you would think about this figure, ladies and gents, it really doesn't matter if you rotate that figure. Picture a box in front of you that you're going to give as a gift. You can turn that box any way you want. It's the same box. So my suggestion, immediately label a length and a width and a height, knowing that it doesn't matter. So anywhere I see a length, I'm going to go ahead and substitute in 10 centimeters. Anywhere I see a width, I'm going to go ahead and substitute in 4 centimeters. And anywhere I see a height, I'm going to substitute in 8 centimeters. Now this will look awfully familiar to you. After all, the 10 by 4 gives us that rectangle that was 40. 10 by 8 was 80, and 4 by 8, 32. If you were to put those together, you'd get 152. And if we were to double that, well, look at there it is again. So, little zoom out here. Two different ways of finding the surface area of a rectangular prism. On the left, you have some kind of drawing method, whether you draw the individual faces or the net. On the right, we have a formula. So I tell you what, this should be on your formula sheet, but if you want to write this at the top of your homework, because that could be one of the most important things that you have for the day. Surface area is 2 times parentheses length times width plus length times height plus width times height. What are the similarities? Mr. Callan, it's the same answer because it's the same box. Not only that, Mr. Callan, I can see very quickly that we should be using square units because we're talking about area. A student with strong skills can use either the drawing method or the formula method, but students with the strongest skills should be able to do both. Now, allow me please to get into one more example, and I'm going to do it both ways, and then we'll have you start your homework up. First thing I'm going to do is draw. And I will tell you that most of my students prefer drawing individual faces, so I'm not going to draw a net, but if you did, your net's going to look something like this. There's the front, right face, back, left face, top and bottom seem a little smaller. But for the rest of us, again, what we can do, draw in a rectangle. Dimensions are 9 inches by 4 inches. And of course, we have 2 of them. So while this area is 36, we actually have 2 of them. All right, I'm going to erase that. Now I'm going to look at the side faces, the left, which happens to be the same as the right, ladies and gents. In this case, I see 3 inches, and if that's 9, then that's 9. Yep, it's 3 by 9, or 27. And I do have 2 of those, so I'm going to multiply by 2. Last but not least, top face and bottom face, which appear to be rectangles that are 4 inches by 3 inches in size. But again, there's a top and a bottom, so I'm going to put times 2. And to find the area, let's go ahead and add those up. 2 and 4 is 6, and 4 is 10. Carry the 1. 1 and 7 is 8. 8 and 5 is 13. And 2 is 150 square inches. Now let's carry on with the formula. Well, I'm going to write surface area of any rectangular prism is precisely double the length times the width, the length times the height, and the width times the height. Now, if you want, go ahead and pause the video. Come on back when you're ready. First thing I'm going to do, for whatever reason, I always fly to the height first. I don't know why. I'm going to call 4 the length. I'm going to call 3 the width. But remember, you can turn that box any which way and it's going to have the same area. So you can identify anything you want. I'm going to substitute in 4 for length, 3 for width, and then I will substitute in 9 for the height. These numbers will look familiar. 4 times 3 is 12. 4 times 9 is 36. 3 times 9 is 27. But now I'm actually going to add up the pieces before I double it. 10, 40, 60, 73, 75, and perhaps not surprisingly, same exact answer. So again, look at these problems. How are they similar? How are they different? You will see both of these. You'll have a 36. Looking at the 9 by 4 rectangle in the front. Both of them, you'll have 27. And that was looking at the 9 by 3 side faces. And both of them, let me make this a little lighter. You'll have 12 on both, because that was looking at the top and bottom faces. All of them, you'll have times 2. Only on the left, you double it before adding. On the right, you add before doubling. And then one last thing to really emphasize. Understand what you are measuring. We're not doing inches of ribbon wrapped around this box. We're not doing cubic inches of air that you're filling the box with. You want to know how many square inches would it take to wrap all the way around that present. So pause, rewind if you need. What is a net? A net is if you took a box and you peeled it apart, noticing that some areas are going to match the front and the back, the top and the bottom, the left and the right. How do you find the surface area? You can do the net, find all the individuals and add up, or you can do the formula. Length times width, length times height, width times height, and then double that to find that total one. So that's what I got for you, folks. Whatever the assignment number is, please notice that for numbers 1 through 4, it's making you draw either a net or all the individual figures. 5 through 7, or maybe it says 6 through 8 if I messed up the numbers. It's going to say use the formula, no choice, no drawing. But the second page, the back page, actually gives you the choice. It says either or, and you get to choose, plus a couple challenge problems there. All right, folks, that's what I got for you. Take care, do well. Let's grow. See you.